Let's do this geometry problem from AOPS Introduction to Geometry. So circle O is tangent to all four sides of rhombus ABCD. AC is 24 and AB is 15. From this sentence, we know that all four sides of the rhombus has side length 15. Because according to definition, a rhombus is a parallelogram where all four sides are equal. So the first question here, question A, it says prove that AC and BD meet at O, i.e. prove that the intersection of the diagonals of ABCD is the center of the circle. So we want to know whether or not, so we want to prove that this point here is the center of the circle. Well, how do we do that? Well, since this is a problem related to the diagonals of a rhombus, we're obviously going to use some properties of the diagonals of the rhombus. So what properties do we know? Firstly, we know that the diagonals AC and BD bisect each other. This means that this segment, since we know AC is 24, this segment is 12, and this segment is also 12. And we know that these two segments of BD are equal. Another property we know is that AC and BD are both angle bisectors of rhombus ABCD. So how do we know this? Well, we know this because even without the point O or their intersections, just by looking at AC itself, we can prove that triangle ADC is congruent to triangle ABC because all three sides are equal. So how do we know this? We know that AD and AB are equal and CD and CB are equal because of the definition of a rhombus, i.e. all four sides are equal. However, how do we know this is equal then? Well, this is really obvious, right? AC equals to AC. It's the side equals to itself. Like, there's no explanation here. So obviously then, we know that these two triangles here are congruent. So it's basically this triangle and this triangle. So by proving that ADC and ABC are congruent, we know that angle DAC equals angle BAC. We also know that angle DCA equals angle BCA. So what this tells us is that AC bisects angles DAB and DCB. We can prove the same thing for BD. We can prove that triangle ABD is congruent to triangle CBD because all three sides are equal. And therefore, that triangle ABD equals angle CBD. And that angle ADB equals angle CDB. So BD bisects angles ABC and angles ABC and ADC. So obviously the diagonals of a rhombus, or at least for this rhombus, bisects its angles. So how does this help us then? Well, firstly, let's take a look at some other things we know from this problem. We know that since AD is tangent to the circle, that any line tangent to a circle, so the point of tangency is the foot of this perpendicular line. So let's call this X. We also know that this point is also again perpendicular, so let's call this W. So WX, we can call this point we can call this point Y. And then we can also call this point Z. So we know that there are four perpendicular lines here. So what can we do about this then? Firstly, we can prove, let's say this point, so we know that this point is O, right? Since only the radius is perpendicular to the tangent line. So we know that clearly triangle ODX is congruent to triangle ODY because all three sides are equal. So why? Firstly, OD is obviously equals to OD. There's no doubt in this. Well, why are OX and OY equal? Because OX and OY are both radii. This is why they're perpendicular, because they're both radii. So without this whole radii thing, we are not sure if OX and OY are perpendicular to AD and CD. We also know that DX and DY are equal because of the properties of tangent lines. Two tangent lines from the same point are equal in length. So DX and DY are clearly equal. It's also visually obvious. So therefore, ODX and ODY are congruent. So what does this tell us then? This tells us that angle ODX equals angle ODY, which means that OD is an angle bisector of ADC. So O is on the angle bisector of ADC. Well, what else is on the angle bisector of ADC? We know that point B is on the angle bisector of ADC because BD bisects ADC. This means that since O and B are both on the angle bisector of ADC, O and B are on the same line. And we know that OD is the angle bisector, so OD and BD are so O is on the line BD. So basically, BD is the angle bisector, right? Or is part of the angle bisector. O is on the angle bisector, so O is on BD. So we now know O is on BD, which is one step closer, because the only way we can prove that AC and BD intersect at O is to prove that in the first place, BD and AC both pass through O. So basically we know that O is on BD. Next, let's prove that O is on AC. Well, we also know from this graph and the problem that triangle AOD is congruent to triangle triangle AOX is congruent to triangle AOW. And this is because all three sides are equal. Why? Well, firstly, AO equals AO. That's just true. Secondly, again, the tangent thing. AX equals AW. Thirdly, OX and OW are both radii because O is the center of the circle. So obviously the three sides are equal. So triangle AOX is congruent to triangle AOW. What this means is that essentially, angle XAO equals angle WAO. So OA bisects angle DAB. Well, CA also bisects DAB. So CA is the angle bisector of DAB. OA is also the angle bisector of DAB. So O is on AC. Therefore, we know that BD and AC intersect at O because AC and BD are both straight lines, and two straight lines either intersect at one point or are parallel with each other. Well, AC and BD are clearly not parallel, and they both pass through the same point O, So they intersect at O. Now let's solve, so that's question A. Now let's solve for the area of the circle O. So how do we do this then? Well, firstly, we need to find the radius because area is pi r squared for a circle. So what's the radius then? The radius is OX, OW, OY, OZ. We can find either of these using the Pythagorean theorem because all of these are perpendicular to the sides of the rhombus. So how should we do this? Firstly, let's try and figure out what OD and OB are. So we know that OD and OB are equal to, because AC and BD are perpendicular to each other, because diagonals in a rhombus are perpendicular. We know that according to the Pythagorean theorem, OD equals OB equals 15 squared, which is 225, minus 12 squared, which is 144. That is 81, so that's 9. So both OD and OB are 9. So what does this tell us then? This essentially tells us that, this essentially tells us that we can list out an equation for, let's say this length is A. So let's use a different color. Let's say this length is A. That means the other length is 15 minus A. So we know according to the Pythagorean theorem that A squared plus R squared equals 9 squared. We also know that 15 minus A squared plus R squared equals 144. So solving this, we know that, so if we subtract one equation from the other, we essentially get, so we subtract 1 from 2, so 2 minus 1, we get the fact that we have 30A plus 225 equals 144 minus 81, which is 63. Wait, no, something's wrong. Oh yeah, negative 30A plus 225 is 63. So let me just check. 8 plus 6 is 14, yeah. So negative 30A is 63 minus 225, which is negative 162. So A is 162 divided by 30, which is basically, so 162 divided by 30. So we can simplify this fraction here and divide both of these, top and bottom, by 2. We get 81 over 15. Divide top and bottom by 3. We have 27 over 5. So if A is 27 over 5 and OD is 9, then we know that the radius here is going to be root 81 minus 27 over 5, which is, so 27 times 27. 7 times 7 is 49. 2 times 7 is 14. Plus 4 is 18. The other side is 54. We have 1 plus 5 is 6. 729. 729 over 25. So this gives us that the radius is, so 81 times 25. So what's 81 times 25? 5 times 1 is 5. 5 times 8 is 40. And then this side, 1 times 2 is 2, 2 times 8 is 16. 4 plus 6 is 0, 1 plus 1 is 2. So, this is 225. So basically, basically from this we know that this is root 2025 minus 729, which over 5, which is, so 15 minus 9 is 6, 11 minus 2 is 9, and then 9 minus 7 is 2. So 1296 over 5, root 1296 over 5. So let's just not simplify this, because area is pi r squared, which is pi times 1269 over 25. And that is our answer.